Example 5 asks us to use the left-hand Riemann sums to estimate the area between f of x and the x-axis, and we've been given the following data. So what I've done first is I've just kind of sketched myself a picture of what I'm dealing with here. So I've got my f of x here, and I put the values of the x values and the y values in here, and I get a graph that looks like this. So the patterning of the graph kind of looks like this. It's kind of going up to here, kind of looking like that. Okay, so there's my function, and I want to find the area between f of x and the x-axis. Now, it's important that I recognize that I'm finding area and not displacement. So when I do my left-hand Riemann sums here, so I'm going to draw my left-hand Riemann sums, the areas that are below, although normally the displacement would be negative, the area I need to make positive. So basically what I'm looking for is this. I'm looking for the area is going to be equal to the integral from a to b, and we're just going to take the absolute value of the f of x values, like that. So when although it's underneath, this is negative 20, I'm just going to sign it as positive. Okay, so although it's below, it's positive 20, we're going to use 20. This has an interval width of 1, a height of negative 2, so it's going to be 2. So this area is the displacement is negative 2, but the area is 2. When I do these areas, just be careful when we have a 0 height, that's going to give us 0 area. Okay, so please don't make a rectangle there. This has 0 area. This left edge here is going to give us this rectangle here. And so this has an interval width of 2, and the interval height is going to be 6, so it's going to be an area of 12. Okay, displacement of positive 12, an area of 12. And this rectangle, left-hand Riemann sum rectangle, has a width of 2 and a height of 8, so it's got an area of 16, and the displacement is positive 16. So since we're talking about area, the area is going to be equal to, the negative parts are going to become positive, so we end up with negative 22 becomes positive 22. And then we add on the positive parts. We have an area of 0 plus 12 plus 16. Okay, so the total area is going to be equal to 50 units squared. Now, be careful because this is the area. If we were asking for displacement, so if the problem was asking us for displacement, we would then be talking about the change in the antiderivative function would be negative 22, okay, plus 28, so that we would have a plus 6 displacement. Okay, so this would be the displacement, or the change in the antiderivative, but not the area. Okay, in a problem velocity problems, when we do velocity problems and you ask for the distance, that's the same as the area. The distance, the negative displacement has to be calculated as positive distance.